Hey everyone, today we're going to be introducing frequency distribution and how to apply it to categorical data. To start, a frequency distribution is a summary table that displays the classes, counts, and proportions of a data set. The labels or classes represent each unique value in a data set. The counts or frequency is the number of observations for each class. The sample proportion or relative frequency is the frequency of each class divided by the total number of observations. This can be calculated by dividing the number of observations for a category by the total number of observations in the data set. Let's look at an example. Suppose we selected 500 people nationwide and asked them what cell service provider they use. Let's construct a frequency distribution for the data set. So for your frequency distribution table, you'll have your three columns: category, frequency, and relative frequency. The category values are going to comprise each unique cell service provider, and the frequency will be the number of observations for each unique cell phone provider. Now we can calculate the relative frequency for this data. So the total number of observations is equal to 500. So we will say 54 divided by 500 equals 0.108. 113 divided by 500 is equal to 0.226. 20 divided by 500 is equal to 0.04. 73 divided by 500 is equal to 0.146. And finally, 48 divided by 500 is equal to, not finally, but that is equal to 0.096. And now for the final one, we would say 192 divided by 500 is equal to 0.384. And with the relative frequency, you can sum them all up at the end, and it should equal to 1. Although it may not be exactly equal to 1 due to rounding error, but that's okay as long as it's pretty close. Now, what kind of information can we derive from this data we have? For example, we could ask what proportion of people surveyed chose not to use Straight Talk. So what we could do is we would say 1.0 minus 0.384, which would come out to 0.616. Or we can ask what proportion of people went with Verizon and T-Mobile. So we would say 0.226 plus 0.146, and that would equal out to 0.372. So let's look at another example. I took the liberty of doing this in Excel so I could show you some neat tricks that you can do. So for example, if you want to quickly calculate all the relative frequencies, you can input the function equal sign B16 divided by 912, which is the sum of all these. And then you can take this, just drag it down, and it will give you all the relative frequencies. And then you can take this, sum it up, and it comes out to 1. Another cool thing you can do with Excel is create bar charts. So, let's see here. Insert. We'll do it this way. And there, you can create a bar chart. And on the vertical axis, you have your observed frequencies. And on the horizontal axis, you have your unique categories. Now with bar charts, you can either use the frequency on the vertical axis, or you can use your relative frequency because they look the same graphically. So demonstrate here in a second. So graphically, they look exactly the same because it's just based on proportion, but unless otherwise specified, we plot with just the regular frequency on the vertical axis. Another way of visualizing this data is to construct a pie chart. So we will select our data. And boom, there we go, pie chart. And it's a lot easier to construct in Excel than it is by hand, just because it's going to be sloppy by hand, even if you have the proper tools to measure angles and stuff, protractors and whatnot. If you found this video helpful, please be sure to like and subscribe, and hopefully within the next few days I will have another video on frequency distribution up and how to make a frequency distribution for numerical data sets.